Okay, let's go ahead and get started. Right, this is project 1. In this video, I'm just going to be covering part 1. Now, my first thing that I would tell you to do, which many do not, is read the instructions. I promise you everything that you need to code is within the instructions. Not only is it within the instructions, it gives you a nice example here, right? It's not going to be the exact one you need to program yourself, but it will be an example that will help you with the exercises. So part 1 says open a new script. Please don't do a live script. If you do, it's okay for this one, but sometimes live scripts are a little bit difficult for me to run on my computer. For whatever reason, they cause an issue or don't run all the plots. It says open a new script and type your name and student ID number as a comment in the top 2 lines, right? And it tells you first name, last name, student ID. Notice that here we're using, right, the % sign for a comment. So let's go over. Let's see, hopefully this works fine. Good. I've opened up a new script, right? And I'm going to write my first 2 comments. I have Clayton Ragsdale, and I'm going to make up my ID number. I don't have one. Okay, let's go back. So it says for the remainder of the project, A is the last digit, B is the second to last digit, C is the third to last digit. This should all look familiar by now because it is the same as your previous projects in 262. So A is the last digit, B is the second to last digit, C is the third to last digit, and D is the sum of A plus B plus C, right? I try to leave it as abstract as possible. You don't need to put 7 plus 6 plus 5 or do it yourself. Again, these semicolons are so that it does not output to the command window if I run it. And something that's always good to do, now you don't need to do it right now, is I'm going to control save. It's going to ask me to save something. Let's go ahead. I'll just say, let's do Ragsdale Project 1. All right, so it's saved. A good thing to do with your code is just to run it. You can't see up here. It's out of this window that's my recording. But you can see the code runs and there's no issues, right? I'm looking for errors with the code. There's no issues here, so let's go ahead. We'll go back, and we'll keep reading. So that was 1A, and so even better. So what we're going to do is let's put a comment here, so it's easy for me to see. This is 1A, and now we're down to 1B. Okay. Let's go back. 1B. Consider the following scenario where you are shooting a free throw on a basketball court, neglecting air friction and wind resistance. A free throw is 15 feet away from the basket on a basketball court. You should shoot the basketball towards the basket from an initial height of y0 and an initial launch angle measured in radians, right? So it gives you these 2 different measurements with an initial velocity, etc., feet per second. These dimensions should guarantee a made free throw. Check if it passes through the near point 0, 10 for a made shot. Use the projectile motion equations given below to define a 2-dimensional parametric system in MATLAB for your made shot and plot the direct trajectory of the ball for 0 to 1.5 seconds. And it gives you the x value and the y value in parametric equations. Okay, so let's go ahead. Go back to MATLAB. Let's first define, because we're going to use these parametric equations using the symbolic variable t. So I'm going to say sims t, and now we have that y0, right? Which this is fine to denote a variable using a number here. That's okay. This was our equation for y0 given in the instructions. And again, I'm putting a semicolon so it doesn't output everything. I also had a beginning measurement for θ0. Again, all this right from the instructions. What was it? Let's see. Equals, was it negative? Negative 0.03 times y0. Good. Oh, plus 1.1. Plus 1.1. It's hard for me to go back and forth. I'm looking at the instructions here. And we also need a V0, right? Those were the 3 beginning measurements, and V0 was negative 0.8 y0 Oh, be careful here. So that's an easy mistake to make, right? I have to tell the computer that I want to do multiplication. Plus 30. Right, I'm going to put a space. Just those were my 3 beginning measurements, theta naught, y naught, v naught. And now I'm going to write out my parametric equations, right? Here's what we actually needed a Sims T for. So let's say x is equal to, the equation said v naught times cosine of theta naught. It's nice that it puts the parentheses for us. Let's step outside this, times t minus 15. And again, semicolon. So it does an output. Let's put the y right below it. So y is going to be equal to negative 16 times t squared plus v naught times sine of theta naught. And we have one. Let's see, theta naught has one. We need one more, right? Parenthesis. That'll go with that one. And times t plus y naught, right? So all from those parametric equations that were already given. And I do control save, right? So I'll save it and let's run it. Good, so no errors. That's the important thing. So after every time you write a piece of code, run it. If it has an error, you'll know immediately where it happened and you won't start writing bad code on top of bad code. Okay, and then the last thing here is let's do figure 1, right? It wants us to plot it. And so figure 1, we're in 2 dimensions, so we can use fplot is fine. We'll just say x comma y, and then I believe we wanted the interval of, I think it was 0 to 1.5 t. And this is fine, so control save. Let's see what happens when we run it. We should actually have a plot that comes out, and this is what your first plot should look like. Okay, so this is it. This is all I'm doing for part 1, right? I got you guys started. Now, I'm going to read part 2, or 1C2, which is the only remaining part of part 1, right? Part 1C, let's go back, and we'll talk about how 1B and 1C are exactly the same abstractly. Right, so 1C, consider the following scenario. Read 1B, consider the following scenario. Right, you are given some radius and some height. Right, the same way up here, you were beginning these theta naught, y naught, and v naught. Right, so you had these things that you needed to just initialize to begin with. Let's see what else. It then gives you some parametric equations. So above, we had parametric equations in 2 dimensions. You now have parametric equations in 3 dimensions, and I understand be careful with the parentheses to make sure you get them right. Right, it does tell you this thing here, I know it's cut off, is the domain from 0 to your height. Right, from 0 to your height. Now you already have Sims T parameterized, so you don't need to worry about that either, right? So essentially for 1C, you need to go through initialize H, initialize R, go through also create X, Y, and Z, right, your parametric equations. And then it says once you have these operations written in proper MATLAB syntax, go to your editor menu, click run, etc. Right? So let's see. And it also says plot. Right? Use these and use plot. Now the only difference here really is this is in 2 dimensions and this is in 3 dimensions. However, if you scroll up in your directions, you'll notice that there's an fplot here, right? That's what we use for 2 dimensions, and you'll notice 3 dimensions, right? It's giving you right here. We did this, 2 dimensions parametric systems. Here's our 3-dimensional parametric system. So what do we use for plotting? We use fplot3, right? So it's very similar, right? So I'll leave you guys with that short 10-minute video. Hopefully that helped. I'll post another one here probably midday for part 2.